So I'm going to talk about static analysis. So first of all, what is static analysis? So if we search on Google, static analysis, also called static code analysis, is a method of computer program debugging that is done by examining the code without executing the program. It involves understanding the code structure and can help ensure the code adheres to standards. And then Wikipedia also has this to say: static program analysis is the analysis of computer software that is performed without actually executing programs, in contrast with dynamic analysis, which is the analysis performed on programs while they are executing. So basically, we're going to write code that's going to go look at our code and tell us something about it. So what are we going to actually say about our code? Well, I have here a example code base checked out. This is the source code to Grafana. It's a AngularJS application written in Typescript. And so I have this method here, getNavModel, and I'm in VS Code editor right now. And if I say find all references on that, this little box pops up here where I can see everywhere this thing is referenced. And what is a reference? A reference is anywhere where that identifier, that getNavModel token, that identifier is used in the program. So we can see that identifier is imported here in this other file. The identifier is also referenced here in this call expression, which is where we're calling this function, the function corresponding to this identifier, getNavModel. So basically everywhere this function is called is the simple way to put it. And so here this identifier is referenced again in a call expression with various arguments. And now what the heck am I talking about call expression? So if you're not familiar with ASTs, you can watch some of my other videos, but I'll show you a brief introduction. So if I grab this code here and we go over to Google and search AST Explorer and paste this code in, you can see if we click on this getNavModel, that is an identifier, that is the type of node in this tree. This tree represents our program. And so this identifier is the value of the expression of the call expression. So this is the call expression. The entire function call with all of its arguments, that's the call expression. The identifier is the part where it just has the name of the function. And then the arguments of the call expression is an array of these two things we're passing in: a property access expression, which is where we call state.navIndex, and a string literal. And so for our static analyzer, let's say we need to find all of the places that getNavModel is called within the program and what strings are passed in for the second argument. We want to get a list of those. So how would we go about doing that? So we could write a static analyzer, and what that will be is code that uses the Typescript Compiler APIs to parse the code, and not only parse it, and so what is parsing? Let me start there. Parsing is when it actually takes the text over here, and, well, first of all, it gets lexed. This text gets lexed into tokens, a token stream, and a token is just like, okay, here's a character, and like it's very low level. And then the tokens get assembled into an AST by the parser, which is this tree we're looking at over here, right? And so the TypeScript Compiler API lets you feed in source code as text, and it will parse it and give you an AST that you can work with. So you can like access this tree and walk it, traverse it, do whatever you want, manipulate it. And so furthermore, the compiler API also understands some of the structure of the code. So it allows you to do things like we just did over here in the code, where we're like, show me all the places this thing is referenced. Likewise, if we're over here where this thing is referenced and you jump to definition on it, you can navigate the structure of your code, right? And so that's semantic meaning that the compiler applies on top of the AST. And so the AST is just like, here are the nodes in your source code, the structure of your source code. And then there's semantic meaning on top of that, like the fact that this identifier references, the fact that this identifier comes from this import up here, to where we can jump to definition on it. And so that's the semantic meaning. There's other semantic meaning in TypeScript, especially like the typing. So when I hover over this, it tells me the function signature. It tells me this thing takes a nav index, which is of type nav index, an ID, which is of type string, and an optional fallback of type nav model. And so that shows me here in this IntelliSense pop-up. When I Apple hover on this or just hover on it, I see its type signature. And so that's another example of semantic meaning that the compiler builds up when it looks at your program. And we can access that programmatically. So we can write a program to look at this. We can write a program to jump to definition and read code and crawl the code base. We can write a program to find all the references and go look at them and look at the strings. And so that's going to be the static analysis we're going to write. So we're going to use this library called ts-morph, and what this is it's just a little helper library that sits on top of the TypeScript Compiler API and just makes the API a little bit nicer to use, specifically with initializing the project and like just giving it a tsconfig.json file, and it automatically goes and adds all the files for you and implements a part of the TypeScript Compiler API called the the compiler host. And what that is it abstracts the interface between the rest of the TypeScript compiler API and the file system. So when you're editing in your editor, even though you haven't saved those files, the contents of like what you're actually still typing in your editor exists in this virtual file system called the compiler host. And so TypeScript expects you to implement that, and ts-morph just provides like a nice, easy to use implementation with some helpers. So we're going to use this thing. Okay, and we're going to do yarn add ts-morph and TypeScript. Okay, so we see that's created in here. And now we can go ahead and create our script. And so we're going to import project from ts-morph. And we're going to do new project. And we're going to pass in the path to the tsconfig. And now we have our project. Let's make sure this runs. Okay, and so there it created a project. It took a while because it was initializing TypeScript and it's doing a lot of stuff when it initializes. But here's our project context or project object with the project context, which is basically a bunch of internal stuff to the TypeScript compiler API we don't really need to be concerned with. We're just checking here that we didn't get an error. We did not, so everything's good so far. We've got our project. And so now we need to start with where the function is defined. So I'm going to open another window here so I can go over to I'm going to open another window here and go over to the Grafana project. And here's where our function is defined here in this nav model. So I'm going to copy the path to that thing. Let's see, copy path. Okay, so we have this script, and we're going to look for this get nav model method. And so we can do project.getSourceFile, and we can do get source file or throw. Get source file or throw is going to make sure that our type is narrowed. Otherwise, we have to check if it didn't get the source file and handle the error somehow, and so we're just going to abort the program if for some reason it can't get the source file, so we don't have to do our own error handling. And so let's see if we get a file here. Okay, could not find the source file. So it turns out we have to put the absolute path to the file here, not just the relative path. And so now when we run that, we get some output. And that's the file object. And there's a bunch of stuff in here, like bind diagnostics, the text that it actually, the text, source text of the file, a whole bunch of stuff in here. What we're concerned with is, we got a map of all the identifiers here, but what we're actually concerned with is the statements, which is the AST nodes, or the abstract syntax tree nodes. And so, let's see. Compiler node is the Typescript node, as opposed to the surrounding object, which is the ts-morph wrapper. We're just going to be concerned with the compiler node. We're going to work directly with the Typescript official API. And we're just using ts-morph to implement that compiler host, that virtual file system. And so this statements array, I was looking for it for a while. This statements array here is an array of top-level statements. And so what do I mean top-level? So if we go over back to the AST Explorer, and we scroll up here, we see here's our source file, which is exactly what we just logged out in the console. And we have our statements array. And so there's only one statement in this file here, but I'll go down here and I'll add like console.log foo. And so now there's two statements in this file. So there's a function declaration and an expression statement. And that expression statement has an expression which is a call expression. The call expression is a property access expression. It has arguments and so on. And so this is a tree. So the root of the tree is the file node. That's this whole source file node. That's an AST node. That's the root of the tree. And then its children are like the statements. But there's more than just the statements. There's other children as well. Like this function declaration node has parameters. It has a body. And so those are all children nodes. There's no like single children array. For example, this call expression has a child node for the name, which it happens to be an identifier node, but it doesn't have to be. It has an array of parameters, and it has a body. These are all children. And then the body is also a node of type block, and it has children, which are statements, and so forth. And so if we want to search through this tree, we need to do some kind of recursion or recursive search. So let's start with something simple, which is like, how do we print out every single node? Not just the top level nodes, but every single node in the entire file. So let's do this challenge here. And so we got file.statements, file.compiler node, because we want to bypass the TSMorph API and go directly to the underlying TypeScript API. We're not getting typing on this. Oh, it's a getter. No. So the reason the typing isn't working is because down here at the bottom in VS Code, it's using TypeScript 2.7 instead of the workspace version. I'm going to switch to the workspace version, which is 3.7, the latest file. or the latest version rather. And so now the file has the correct typings. Instead of any, it's a ts.source file, and on there we can get our statements, and that's an array. So we could do for const statement in of, not in of ts file.statements. We'll log out the statement, and let's go ahead and run this. I'll make this text a little bit bigger. I don't know. People are having trouble reading that. And so now we're logging out each of our statements, which, as you can see, is very, very verbose. So rather than logging out the whole statement here, let's just get the position and kind and log that out. And that should be a little bit of a cleaner output. And there we go. We got 4 top-level statements, but we need to get the children too. So how do we do that? Well, on each statement, if we go back up here and put our statement back in, so on each statement, which is a type of TS node, ts.node like that, there's a function called for each, we need to import ts for each child, and that takes in a node. And what we can do is we can say we're going to have an array, and we're going to push each node into the array, and then we're going to recurse on it, and then return the array. And we'll call this flat nodes. Taz, what you barking at? And so what this is going to do is collect all of the nodes recursively in this array here. So we create an empty array, iterate over every child of the current node, and then we get a node. Every time we get a node, we push it into the array, and then we call the recursive function, so it recurses. Alright guys, I just want to point out there's a bug there. When it calls flat nodes on line 19, it doesn't handle the return value. It needs to iterate the return value and also push that into the array to backtrack the recursion. But I'll correct that later in the video, so back to that. On that child's children, and so on all the way until it reaches a leaf node. And then when we're done, we'll return the array up here. And so we'll say, let's just say in here we're going to push the node itself we're recursing on into that array. And so here we'll say nodes equals flat nodes from that statement. So that's going to include the statement itself and all of its children recursively. And then we can say for const node of nodes will console.log node.pos, node.end, and node.kind. So this node.kind, guys, that's a node.kind is an enum. So in the code it looks like this. The for each child method. It looks at what kind of node it is, and like this one is like some kind of like binary expression which has like a left and a right, and it recurses for you. So like this one, whatever kind that is, you can see it has quite a few children. It has decorators, modifiers, name, question token, exclamation token, equals token, object assignment, initializer. And so you don't need to code your program to do all this. Like they have this utility for you in TypeScript. So that's the source code of the for each child that we're calling there. All right, so let's try to run this here. And so that is every single node in the entire source file recursively flattened into one list. So what we can do from there is we could do if node, well, we want to check the kind. So TypeScript has these helper methods. So we could say if is identifier, because we're looking for the function identifier, what's it called? Get nav model. So if the node is an identifier and node.getText is equal to get nav item, let's double check this naming here, get nav model. So we're searching for a particular node, which is both an identifier node and has the text get nav model as its text. And we're only going to log it out if it matches that criteria. So we're going to search for that particular node, that node being this identifier right here. And so we got it right there. It starts at 341, ends at 353, and it's of type 75. Let's sanity check this here. So if we get this code from the code we're analyzing and paste it in, you see it starts at 341, ends at 353, and the kind is 75. So that matches what we see here. So we found the correct node. So now we want to call we want to find all the references on this node. And so on this get nav model, we want to find all of its references. So we're going to do project dot come on, why is this an error here? Identifier expected. I'm just going to reload the window. Sometimes after you open a big file, like we did in the TypeScript sources, you lose IntelliSense, or it gets bogged down trying to process that big file, and we just looked at that huge, like 100,000 line source to the entire TypeScript compiler, and that just crashed the VS Code language service. So anyways, we reloaded VS Code, and so now we can do project.getLanguageService. And this is going to be a ts-morph wrapper around the language service, and I'm just going to work with the underlying TypeScript API here. So this is the actual like underlying low-level language service, the compiler object. And so we want to find references, and we need to pass in the file name. TSMorph has some nice wrappers around this, but I'm just going to use the underlying stuff here. And so we're going to just say node.end. So what that's doing exactly is it's like we put our cursor inside of this code here, at the end, and then we ask to find all references at that position, at the node.end position, right? So I'm just going to clean this up here. Okay, and so that should be our references, and the references look like this. It's going to be an array of referenced symbol. So we can do for const symbol of references, console.log symbol. So let's run this. And we can see here it logged out the various symbols it found So it's saying that in this file, LDAP user page, at some text span, that it found a reference. And so if we go to LDAP user page over here in the code, we see it does in fact have a reference there. And it's going to find multiple references in that file. So it found 1, 2 in that file. And why is that? Well, this identifier occurs twice in here. So there's a reference to it there and a reference to it there, the import itself. So that would be how you find all of the references for something. But now we want to get the AST node of that call expression where it's referenced, and then from that AST node find the arguments being passed into the call expression and look for that string we're passing as the second argument, right? Because the whole point of this program is to get the list of strings we're passing in. Let me go over to this code. So we want to get this string right here, right? So like we found the text span of this guy, but now we want to find that AST node, and then from the node go find the second argument, which is the string, and then put the string into some kind of array that we're going to output. So symbol.filename symbol.references.filename, or for const reference of symbol.references reference.filename. And this is starting to get messy here. You see how we have this flying V going on, where it just keeps indenting. We're just nesting loops inside of loops inside of loops. And we have like this file up here, and then we're shadowing it here. We have a new file here in a different scope but with the same name. That just gets super messy. So that's a good hint that it's time to create an abstraction. And so we could just, let's say, call handle reference, or I like to say visit reference. And what's the type of this? ts.reference entry. And so we'll handle that down here in this its own method. And so now we need to find that AST node here. So we have its text span at reference.textspan, and that has a start and a length. And so we need to get the flat nodes in this file. And we can't pass the file itself in here. We need to get the file, like the file object, not the string. So get the file from the file name on the reference. And then this flat nodes doesn't take a file, so let's make a function that does, called flat nodes from file, and it takes in a ts.source file and just does file.statements.forEach flat nodes. Actually, let's do it this way. Sorry. For const statement of file.statements, call flat node with each statement, and then we'll have an array here to collect all the statements. And we can actually make this a little bit more efficient. So instead of spreading, which makes a new copy of the array every time, you could do for const node of flat nodes. So we're just pushing into the array. That way we're not making a copy every time. Flat nodes from file, and let's stop for a second and go back up here and refactor. So we could say flat nodes from file up here, and then this goes away. Right, so rather than looping over each statement in the file and calling flat nodes, we'll use a new function we just created, which does the same thing and just gives us the list of accumulated nodes. And this needs to be the compiler node, the underlying TypeScript node, not the ts-morph wrapper. Okay, so let me just collect my thoughts here. So we're in this visit reference function. We have a reference, which is a file name and text span. We go get that file at that file name. Then we have all the nodes in that file. So that's every node in the file. And now we want to find the node where the text span matches the reference. So we have a reference.textspan start and length. And we want to do find. And we want to find the node where the node.get, the node.compiler node.get, let's see, start is equal to that start, and the node.compiler node.end is equal to the start plus reference.textspan.length. So actually we don't want compiler node.end equal to start plus length. We want compiler node.width equal to length. I forgot to edit that into the video, so the code just changes later in the video. Anyways, back to that. So that would be this one. So it's like off by 1 here. So it got 224 instead of 223. So what's happening here is when it's iterating on these nodes, trying to find the node here, it's not finding one where the start and the width match up. And I think that's because down here we're calling flat nodes, but that recursion is not working correctly. So we need to actually do like for const child node of flat nodes array.push child node, because we're not getting all the descendants. So earlier when I said we were getting all of the children in one flat list, I was wrong. So let's see if that fixes it. So now we should get all of the children in the flat nodes list. So when we try to find the matching node in that list, we should find it now because it's actually there, or all the nodes are there. Okay, so it found all these and it didn't crash with any errors this time. So now let's, instead of printing out the name of the method we're calling, we want to get the argument, the second argument, the string. So this node, let me go to the AST Explorer here. This node that we got is the identifier. Its parent is the call expression. And on the parent, there's an arguments property. And it's an array, and so at the one index, or the second element in that array, is our string literal. So we want to do, let's see, first of all we want to say if node.parent, or if is call expression node.parent, because it might be referenced like we might just have a reference to that function, like passing it as a first-class function. We're not actually calling it. So we want to make sure that we have a call expression here as the parent. And in order for type narrowing to work, we need to do this. We'll call this like maybe call expression. This way, in this condition, when we do maybe call expression, TypeScript is able to see that that's a ts.call expression. If we just reference node.parent, it won't narrow. Arguments 1. So rather than printing out the text, let's just print out that right there. Cool, so those are the AST nodes, and we can see the text there, because these are like string literals most likely. Well, they are, that's the only valid type. So we do get text on that string literal. Let's run this one more time, guys. Cool, so there's all the references to where this thing is called, and then the value of the arguments. And so the only thing left to do to like satisfy our acceptance criteria here would be to actually just not log out like this reference. So if we're going to output it, or maybe we want to push this into an array, so maybe we'll do like array.push, push in the value of the text we're calling, and then we'll have like this array up here, and we'll like return this array down here, and we'll wrap this in the function. We'll just call this do stuff because I'm a little bit brain dead here. Just wrote a static analyzer for you guys, and yeah, all my energy is drained. So yeah, you do something like this. So we'll call this like get strings. There, that's better than do stuff. All right, so it creates an array, gets the compiler node, and we can move all this stuff in here. Gets the underlying file AST node out of the ts-morph wrapper, gets all of the nodes in that file, iterates over them, checks if it's an identifier. If it is, checks if the text is get nav model. If so, finds all the like that's how we find the identifier, and we could actually extract this. So we could say function get method just to cut down on some of this nesting here. So it looks something like this. So we create our project. We have a get strings method and get nav model node. So we find the get nav model node, like we go find the method itself. Once we found it, we return it. And then we backtrack up here. We get all the references on that node, iterate over those, get the node for each of those references, get a reference to the parent, check if it's a call expression, if so, push the second argument into an array, and then return the array. And that's a static analyzer. Oh, got one little error here. And yeah, that's how you write a static analyzer in TypeScript, or at least a very basic one to go find a method and then find references on it and then check if those references are call expressions, and if so, get the string argument and collect them in an array. And so in a future video, I'll do a more advanced static analyzer video where we'll do like some more computer science type stuff, because right now it's kind of just like this, like find the method, find the references, get the string, just boom, boom, done. A more advanced static analyzer might have to do something like build a dependency graph, where we'll do like various computer science things like recursion and backtracking and graph theory, and things like hash maps for detecting circular references. So yeah, if you like this, drop a like or a comment, let me know. Give me some motivation to make that follow-up video, because that one's not going to be easy. All right, hopefully this helped. I know this was really tricky for me to figure out because they don't have a lot of documentation for this stuff, and I had never really worked with anything similar in the past before I kind of was challenged to work on this. So hopefully this helped you guys. Thanks.